so if let me erase this. Clear on
Are you taking AP Physics this year?
what?
Are you taking AP Physics this year?
Yeah.
Have you
So,
gone through the you can't run for momentum whole thing?
bro, we haven't even started learning about momentum.
What?
Yeah. Like Carter's really behind this year.
Oh, why?
I don't know. He spent like we spent like 4 months on kinematics.
Jeez.
Like kinematics is so freaking easy. He spent like years
Huh.
on that. Okay,
Yeah.
so let's just say you have a ball. So let's just say this is a hill, okay?
Yeah.
Uh, there's a ball, and what you expect is that at the beginning, its speed is gonna increase really fast. It's gonna go
Uh-huh.
down faster and faster and faster. But then when it gets closer to the bottom, it's gonna start slowing down, right?
Uh-huh.
So what momentum is going to do is it's going to start updating. So if you take a look at our bias graph, it's going to start the updating process really fast. So it's going to go like this, and then it's going to slowly slow down the updates. Okay.
Okay,
Oh,
so I think the reason are we basically trying to decrease the momentum?
no, so what we're
Or,
doing is trying to simulate. So if you think of this ball as the model's position on this cost function hill, right?
yeah.
What we wanted to do is we wanted to quickly go down, but then as it gets closer to the bottom, we want it to slow it down so then it doesn't go so far and it goes like we.
Yeah, no.
Yeah.
So basically, I think decreasing momentum as fast as you can or something like that. I think
Oh, I
like
didn't learn about the concept of momentum yet, but
oh, okay,
like
okay. Yeah, yeah, yeah. Then it makes more
it,
sense to me if I say it that way.
yeah. Okay, so what you gotta do is okay, so let's start about talking about speed and position. So that should be a really easy, quick review for you. Let me share that. Okay, so over here, so momentum, you have the velocity and speed, right? So
Mhm.
your speed and velocity are very different, right? Speed is just the magnitude of velocity,
Yeah,
right?
yeah, yeah, yes, yes,
So
yes.
let's just say, so let's say your initial position is at 0 and your final position is at -4. So your speed in this case is -4 units per step, but your velocity, I mean, your speed is 4 units per
Yeah,
step.
yeah, speed is 4,
Well,
velocity -4 is
yeah.
yeah, direction, magnitude, everything. I got it.
And then over here, this is just if you take multiple steps, okay?
Uh-huh.
So what we're going to do, instead of thinking time as continuous, where like you could have like 5.8 seconds, right? We're gonna think of it like steps, because what we're doing with the model is that we're updating the model through steps. Like for each epoch, that is, so we're just talking about integers here. So it's just steps.
Okay.
Okay, so because it's steps, what we're going to do, we can say that your position is this, is a function, it looks like this, right?
Uh-huh.
So yeah, that's gonna be your position. And then the rate, so that is assuming that your velocity is constant the whole time, right?
Yeah.
Okay, but like pretty much your velocity doesn't stay the same, because you remember you remember like a ball rolling down a hill, like its velocity increases at the beginning and then it starts to slow down.
Yeah.
So its velocity is not going to be the same. So that is acceleration, right?
Yeah.
The rate at which your velocity changes. So
It's
let's
basically
say,
second derivative position. Yeah. Okay, hold on.
yeah. Okay, so
Uh,
what we get is if the acceleration is the same, is constant the whole time, then your velocity is given by this function, right?
yeah.
Okay. So so what we need to do is to update the position of the particle, which is like to update the position of the model on the hill of the
Uh-huh.
cost function, right? We need to first update its velocity using the function we defined here. but then update the position, right? Okay, so the problem is your acceleration is not constant, right? Because your
Yeah.
acceleration is pretty much given by your acceleration is pretty much given by what's it called? The force you apply, right? So the force you apply, you remember F equals ma? Yeah.
Mass
So
times
we're just gonna
acceleration.
get rid of the mass in this
Mass. Okay.
position. So what we're gonna think about force. So force on a hill, when your ball is rolling down a hill, right? There's
Yes.
friction. There's always
Yeah.
friction.
Uh-huh.
So friction is going to be mu, okay?
Okay, I see where we're taking this. Yeah.
Okay, so friction is gonna be mu. And then what we're gonna do is so friction is gonna be a value, but the coefficient of friction is gonna be between 0 and 1, right?
Yes.
And then so we're gonna multiply that by our current velocity, okay?
Okay.
And then we're gonna add acceleration. So acceleration though, what we're gonna define acceleration is, we're gonna define acceleration as your gradient. So acceleration is going to be equal to, wait up. Yeah, acceleration is going to be equal to your gradient, which is the learning rate multiplied by the partial derivative, right?
Okay.
Okay, so what we get is that your velocity is going to be mu times the velocity. So mu times the velocity is like how much your velocity, how much of your current velocity you keep because friction is in the way, right?
Uh-huh.
And then this variable is the extra force you apply by the update by the gradient, which is dependent on your learning rate and your partial derivative at the point you are currently at.
Okay.
Okay. And then we just and then we just change the position using the velocity.
Uh-huh.
Okay. So, Aiden, I'm gonna come back to you after I show him the code. So just study this piece of code. Wait, do you know what has attribute is?
Oh no, I have not learned that one.
Okay, so yeah, I didn't know that one either, but it's like really simple. So what it does is that you take an object, okay? So
Yeah.
object in
A
this case is
layer.
layer. And then
Okay.
so what we're trying to get is we're trying to get layer dot v weights, okay? So this is what we're trying to get. We're trying to get layer dot v weights. So if this object layer has the attribute, the velocity and the weights, and if it doesn't, we're gonna get false, right?
Yes. So
So
does it?
then if it's false, then we're gonna create these for the layer.
Okay. Okay.
And then we
Yeah.
use zeros, like because velocities start at 0.
Wait, what
So
does the function NP zeros like do again?
it gives you oh yeah. So it gives you a matrix of zeros, okay? It gives you like a bunch of zeros.
Uh-huh.
And then but then the shape, you know shape, right?
Yes.
Shape is row by column. So the shape is going to be the same as layer dot weights.
Oh,
So
okay.
because if we have like a 4x3 matrix,
Is it
so
just gonna make a 4x3 of all zeros?
yes, because
Okay. Okay.
each parameter we want it to give a velocity.
Yeah.
Okay.
Oh, I see that in the comments of the code. Okay.
Yeah.
Yeah. Self you don't wait self mu times. Oh, so you just replace. Okay.
Yeah.
So you're basically just optimizing the optimizer.
Yes. You're trying to make it better.
Yeah.
Okay. Yeah. Okay. So mu is something you need to set yourself. So if mu is 0, right? That means we're not
No
using
friction.
Yeah, we're technically not using momentum if we have mu equals 0.
Uh-huh.
Okay, because if mu is 0, then if you calculate, it's just your velocity is just going to be your gradient, right?
Yeah.
Okay. Aiden, you there?